Hi, welcome to Code.io. In this video, we'll be looking at parenthesis checker. So, if you know what a stack is, if you don't know, please check that video out. We have already done a video on stack and it completes the concept along with the programming. And so, if you haven't checked it out, please go ahead and check it out. And one of the applications of stack is called parenthesis checker. Okay, so here by parenthesis they mean all the brackets. Okay, so brackets checking. This is primarily used by compilers to check if you have properly closed all the brackets that you have opened. Okay, and the order as well. So that is what we are going to do now. So in this example, you can see that we have. Let me just take the pen. Okay. So we have 3 open brackets and 3 closing brackets, and they are in the right order. So what do I mean by the right order? Here we have opened a square bracket and we have closed it as well. Similarly, we have opened a parenthesis and we have closed it, and a curly brace as well. Okay, so and they are in the right order, right? The box bracket is the one opened at last. I mean, the square bracket is the opened at last, and it has been closed first. So like that is how we do, right? For example, just consider a main function or some method for that matter. So you have curly braces for that method. Okay, inside that you might be defining an array. For that you would require the square bracket and you would close it immediately. You will not wait for the curly brace to end, right? So that is what we are going to do now. We are just going to check if we have the brackets opening and closing, I mean the matching pair, in the right order. Okay, so how do we do that? You might have noticed that I said the square bracket is the one opened at last and we are closing that first, right? So does this ring a bell somewhere? This is what we call last in first out, right? The square bracket is the one that came in last, and it is the one which is getting its pair first. So this particular concept, last in first out, right? LIFO. So this concept you would have heard if you know what a stack is. So again, I'm just telling it again and again. If you haven't learned what a stack is, please go check that video out. It has everything covered, and you will understand this way better if you know that. Okay, so this is called last in first out, and stack is a data structure that uses this concept. Okay, the element that comes in at last will be the element that is getting removed first. So that is that, and we are going to use the stack data structure to solve this question. So how exactly are we going to do that? We'll see that now. So consider this a string. Okay, the parenthesis, right? The input format is probably string. So you are getting this string of brackets. So what you are going to do is you are going to traverse through the string. Okay, traverse through the string and perform the following functions. Okay, so what exactly are those functions? So the first one is, like, you can consider it like rules that we follow to solve this problem. So first let us consider a stack. Okay, so I'll just draw one here. Okay, so we have a stack here. Now what you're going to do is you are going to traverse through this input string. Okay, the input string is just a string of brackets, right? So you're just going to traverse through this, and we are going to do the following things. The first, we'll solve this particular problem and you'll get to know what the rules are. Okay, the first character here is an open curly brace, right? This one here, it's an open curly brace. So whenever you encounter a open bracket, it might be an open curly brace, open square bracket, open parenthesis, it doesn't matter. If it is an open bracket, push it into the stack. Okay, initially the stack is empty. Okay, now we are going to push this open curly brace into the stack. I tried to draw it really nice, but it just did something. I'm just trying to Okay, not bad. So it is an open curly brace and we pushed it into the stack. Now the stack has one element and it is open curly brace. Now what we are going to do is we are going to move to the next element, which is open parenthesis, right here, this one. We have moved to the second element, which is the open parenthesis, is again an open bracket, right? So whenever you encounter open bracket, you push it into the stack, and here goes the parenthesis. You are pushing it into the stack as well. Now moving on to the third element, and the third element is square bracket, and this particular square bracket is also a open bracket, so you are going to push it into the stack. Okay, so 3 elements done. Now we are moving to the next element, and this is quite different, right? Because this is a closing bracket. Now what we are going to do, the rules that we have designed so far are, if it is open bracket, push it into the stack. Now we have encountered a closed bracket. So what we are going to do is, we are going to check if the closing bracket that we just encountered is a match for the bracket at the top of the stack. I think I am making things clear now. So the bracket at hand is a closing square bracket, and what we have to do is, this is the first closing bracket that we have encountered, right? So whenever we encounter a closing bracket, you are supposed to check if it matches the bracket at the top of the stack, the opening bracket at the top of the stack, right? If it is matching, we have to check if the current bracket is matching the one at the top of the stack. So the one at the top of the stack is opening square bracket, and the one that we have just encountered is closing square bracket, and it perfectly matches, right? So we are checking if this is a match for this one. Okay, we are checking if the bracket at the top of the stack is a match for the one that you are currently looking at. It is a match, and hence you will have to pop this element from the stack. You are going to pop it and just continue. Okay, so here comes a couple of questions. So in this particular case, it did match. Okay, it matches the bracket, opening bracket at the top of the stack, so you are just going to pop it and continue. But if it doesn't match, you can just go ahead and say that it is not a valid set of parentheses, or it is not a valid set of brackets, it doesn't match. Okay, so we will come back to the doesn't match part later. You don't have to worry about that now. Now we are just going to move to the next element, and the next element is closing parenthesis. So whenever you see a closing bracket, what do? You check if the top of the stack has an opening bracket which matches with this. At the top of the stack we have opening parenthesis, and now we are at closing parenthesis. It matches, so not a problem. You are going to pop this element from the stack and going to continue with your work. Moving to the next element, which is closing curly brace. Okay, again a closing bracket. So you are going to check the top of the stack. Top of the stack here has opening parenthesis, opening curly brace, which is a perfect match for our current bracket, so it's fine. You are just going to pop the stack. You are going to pop the stack and continue, but there is no other element remaining in the string, right? So you have considered every single element in the bracket string, and you have performed the following functions. Now what you'll have to do is, once the string is over, once you have traversed the entire string, you have to check if the stack is empty. You are going to check if it is empty. Now is the stack empty? The stack is empty, right? So this means that the current string that we just traversed, it's a valid string. You can return true. this is a valid parenthesis string. That is what we are going to return. Okay, so in this example we have come up with a couple of rules. I mean, we didn't come up with that. We have learned a couple of rules. So the first one is, if you encounter opening bracket, push it into the stack. Okay, we have done that for the first half of the string. Until then we didn't encounter a closing bracket. In the second half we encountered only closing brackets. So what we did was, we were going to check if the top of the stack had the matching bracket for the one that we have currently at. So if you encounter a closing bracket, any bracket it might be, if you encounter a closing bracket, check if the top of the stack has the matching bracket. If yes, it's fine, pop these elements and move on to the next bracket. Okay, because you have found the matching bracket and this particular closing bracket is done. It has been matched with this opening bracket, done. Okay, so you can move on. If it is not, you will have to say that it is not a valid thing. So that is what we are going to look at now. We are going to see an example where it is not a match. Okay, so here it is. Let me again just draw a stack. Okay, so we are going to traverse through this bracket string again, and the first one is open parenthesis. Whenever you see open bracket, you will just push it into the stack. Now the stack has open parenthesis. Now we are moving to the second element in the string, which is open square brackets. Okay, and again it's an open bracket, so you can just excuse me. So again it's an open bracket, so I am just pushing it into the stack, and the stack now has a square bracket and a parenthesis. Okay, and we are moving to the next element. The next element is closing square brackets. Okay, so whenever you encounter a closing bracket, you are supposed to check the top of the stack. Now this here at the top of the stack is a opening square bracket, which is an exact match for our current bracket, right? So what do we do now? We are just going to pop these elements. Okay, so we are going to pop the open we are going to pop the top of the stack. That's it, because it matches with our current bracket. Okay, done. Now we are trying to move to the next element in the stack. We are trying to move to the next element in the string, but the string is over. So we have traversed through the string, but we have to check if the stack is empty. Here the stack is not empty. It means that it has one unmatched or unpaired bracket in it. Okay, it might have any number of elements, that doesn't matter, but if it is not empty, this is not a valid phrase. This is not a valid bracket string. Okay, because the stack is not empty. If it were matched with every single bracket, the stack should be empty, because whenever you encountered a closing bracket, you have removed the matching bracket from the stack, right? But we still have an opening parenthesis, which means that this is not a balanced parenthesis string. Okay, so we will have to return false for this. Now you might also encounter one more type of input. So let me just draw that here as well. So instead of this string being only 3 characters, let me add the 4th character and let it be closing curly brace. Okay, now in the previous step we just popped the opening square brackets because we found the closing square bracket, right? Now moving to the next element, we have closing curly brace. Now whenever you see closing curly brace, what do? You check the top of the stack and see if it is a matching pair. Now here the top of the stack contains opening parenthesis and not curly brace. Opening parenthesis and curly brace are not exactly matching, right? So in this case as well, you are just going to return false. because this is not matching. So if it is not matching, you can straight away return false. Okay, if not, it means that the string has finished already, but the stack is not empty. In that case also you will return false. Only if all the characters in the string are processed and the stack is empty, that is only when you say true, the parenthesis is a valid one. Okay, the parenthesis string is a valid one. So that is only case where you say that yeah, this is the right pairs of brackets. Okay, in every other case you are just going to say false. So I hope you understood this logic. Now we'll try to program this. You will get a better grasp on this. So this parenthesis checker is actually in Geeks for Geeks practice, but I'm just going to solve it here in IntelliJ, and we'll paste the solution there to check it if it is properly working. Okay, so we have to fill this function. The function's name is par, and it is getting a string as input, and you are supposed to find if the string has balanced set of brackets. Okay, so now what exactly do? We first want a stack to solve this problem, right? So we are just going to create a stack, and it is going to store characters in it. Okay, so I want to make that very clear. Character stack, because the brackets, right, opening brackets, closing brackets, square brackets, parentheses, those are just characters. So we are creating a stack that can store characters. Okay, we have created the stack. Now what you are going to do is you are going to traverse through the string. Okay, so I'm just going to use a for loop for that, and maybe what we'll do is we'll just use the toChar array method so that the string is converted into character array, and the character C here is assuming every single value that is present in the character string or the character array. Okay, fine. So this for loop is going to iterate through every single character in the string, and C is going to be the element that is going to assume its values. Now what you have to do is you will have to check if the current character is a opening parenthesis or a opening bracket. So that is what we did there, right? So we are just going to do that, and you can just see if it is opening bracket by using three conditions, like if it is opening curly brace, if it is opening square bracket, or if it is opening parenthesis. You can give all these conditions here, but I think it would be better if you used a method for this. So I'm just going to define a method called isOpen, and it is going to get this C, the character that we are currently considering, right, it as an input, and it is going to return true if it is an open bracket and false if it is not an opening bracket. So I'm just going to write the method here. So static boolean isOpen. Okay, and it is getting a it is getting an input, right? Let that be A. A is the input that is getting, and it is a character. And now you have to check if it is a opening bracket or not. So we are going to check if A equals curly brace, opening curly brace. If it is opening curly brace, you can return true. The other condition you can check is if it is opening square bracket. If it is opening square bracket, you can return true. And the last one is if it is opening parenthesis. If it is opening parenthesis, you can return true as well. Okay. Now if all these conditions fail, it means that it is not an opening bracket. In that case, you can just return false, and that is it. This is a very simple method that is going to check if the bracket that we currently have is an open bracket. Okay, so we have just called it inside the if condition. It means that it will come inside the if condition only if the method returns true. So if it is an open bracket, it comes inside this if condition. So what do we do when we encounter an open bracket? We just push it into the stack, right? So stack dot push of C, because C is an open bracket. whenever we see an open bracket, we push it into the stack. Now we'll come to the else part. If it is not an open bracket, that is when we come into the else part. What do we do when it is not an open bracket? If it is not an open bracket, it obviously means it is a closing bracket, because we are just going to consider opening and closing brackets in this string. We are ignoring any other possibility. So this string only has opening and closing brackets in it. So if it comes to the else part, it definitely means that the current character is a closing bracket. So whenever you see a closing bracket, you check if the top of the element, top of the stack, right? If the top of the stack contains a matching bracket. So you can use the method peek for that, but I'm just going to use the method pop. Okay, so the method pop will remove the element but also return the element. Okay, so why am I exactly removing? We are just going to check, right? I am removing because we don't need it anyway. So if it is a matching bracket, what do? We remove the element. If it is not matching a bracket, if it is not a matching bracket, we are just going to return false. So why give peek and pop? You are going to check if it is matching. If it is matching, you are going to remove it. Instead of that, I just remove it, take a copy of that and check if it is matching. If yes, it's fine. You can continue doing the same process. If not, just return false, right? If it is confusing, just leave it. It is not a problem. The concept remains the same. You are going to check if the top of the stack contains a bracket that is a pair, or that is the one that is matching with our current element, right? So char ch is equal to stack dot pop. Now this is the element at the top of the stack, and we are going to see if it is our current element. I mean the element or the bracket that we currently have. Okay, I mean we are not going to see if it is exactly same, we are going to see if it is a pair. So I'll define another function called matching, and this matching, right, matching will get both these as arguments. Okay, and will say if it is a matching pair. So let me just define this function here as well. Okay, so static boolean matching. So this gets char ch and char c. Char ch is the opening bracket, because we just popped it from the top of the stack, so it definitely is the opening bracket, and char c is the closing bracket that we just encountered, right? So now we are going to see if they are matching. So if ch equals opening curly brace, if ch equals opening curly brace and c equals closing curly brace, because that is its matching pair, right, we have to return true. Okay, I just okay, fine. So if ch is the one that we just popped, c is the one that we are currently at. Now we are checking if they are matching. If ch is open curly brace, she should be closing curly brace. That is when you can say they are matching. So we are checking if ch is open and c is closed. If yes, we are returning true. Now the second condition is for another bracket, maybe square bracket. If ch is equal to opening square bracket and c equal to closing square bracket, we are going to return true again. Okay, now the last bracket, what else is remaining? Parenthesis. If ch is equal to open parenthesis and c equal to closing parenthesis, we are just going to return true. Fine. And it's showing an error. Why? And cannot be applied where? What? Here. Sorry, I just forgot another equals. Okay, now if none of this is true, we are just going to return false, meaning that they are not matching. Okay, so this particular method is going to check if the couple of brackets that we have are exactly matching. So we are taking, we have just encountered a closing bracket, so we have to check if it is a matching bracket with the top of the stack. So we are taking the top of the stack, which is currently in CH, and our current bracket is C, and we are checking if they are matching with this method. If yes, what do? We just go do the same process again for the next character, right? If they are matching, you have already popped it, so it doesn't matter. So if they are matching, you are going to continue doing the same process. If not, I am just going to return false. Okay, because it is not matching, so this is not a valid set of characters, right? So I am just going to return false. Okay, that is it. Now we have one last thing at the end of the method. Okay, now we might have processed all characters, but we also have to check if the stack is empty. I hope you remember one particular case that way. Okay, although we have processed all elements, we have to check if the stack is empty. Only then every single opening bracket will have a closing bracket. So at the end of the iteration, we are going to check if the stack is empty. Stack dot empty. If it is empty, you are going to return true, and if it is not, you are going to return false. So I hope this is it. I am so sorry, we just forgot one small thing, which is that when we encounter a closing bracket, right, you are supposed to check if the stack is already empty. If it is empty, that is no way that we can pop an element out of it, right? So before checking if the top of the stack is a matching bracket, we have to check if the stack is empty or not. Okay, so that is what I have forgotten here. So if the stack is empty, we can straight away return false. Okay, so I hope you understand this. So when you encounter a closing bracket, you have to check if the top of the stack has a matching opening bracket. But what if the stack already is empty? It doesn't mean that it has a opening bracket for this matching close bracket, right? So in that case, we can straight away return false. Hope you understood this. Sorry for the inconvenience. It is a very small condition, but it is a really important one. Whenever you encounter a closing bracket, before popping the stack out, you have to find if the stack is empty or not. If the stack is already empty, no need for any other correction. You can just straight away go ahead and return false. So now we'll try and run this. So all the test cases has been passed. Hope you understood this logic. If you have any questions, please put them in the comments. So it's quite simple. You are just going to traverse the string, create a stack. If it is an opening bracket, push it into it. If it is a closing bracket, check if the stack is empty. If yes, return false. If not, pop the element at the top of the stack, compare it with its current matching bracket. If it is matching, you can go ahead and continue the process. If not, just return false. And at the end, you have to check if the stack is empty. If it is empty, it is a valid parenthesis. If it is not, you can return false. So hope you understood this logic. If you have any further questions, put them in the comments. If you are not completely clear with it, just check the stack video out. You will get a better idea of what a stack is. And yeah, so if you like the video, please like the video, and if you haven't subscribed, consider subscribing to Code.io. Thank you so much for watching. See you in the next video. Bye.